Yo, what's up, everybody? Welcome back. Today, we are trying to do any form of image copy paste on Wayland because I want to write an image editor, and to do that, I need to paste from the clipboard, and it turns out this is not a trivial thing to do. So, I will often do something where, like, I take a screenshot, boom, hit copy, boom, and if I go into like color paint, because it's like paint, I hit paste and it shows up there. How does that work? Not really clear at this point in time, but when I was looking into windowing libraries for the image editor I was going to work on, I was like trying to decide, like, I think that like copy paste comes from the windowing library. And I was looking at like SDL for if I was going to do I have to make a decision on whether or not my image editor is going to use OpenGL under the hood. I'm not really sure if I want to leave some things up to the implementations of the OpenGL driver. So we'll think about that later. But I was looking at SDL2 for if I was going to do software rendering. And if we look at the clipboard support here, they can only get text. They don't have any options to get images. And if we look at GLFW for if we were going to do OpenGL, they kind of have the same thing going on. They have clipboard support, and they say we will get the string if it contain we will get the clipboard contents if it is convertible to a UTF-8 encoded string. So why only strings? I would think that if I were to just get the clip, like hit paste, I would be able to ask like what's in there. Why does it have to be converted to UTF-8? Not sure. And so I wanted to look at how would we get image data, right? And so I was looking at like, well, we've written a Wayland client, so how hard can it be to like get clipboard data off that thing? So I was looking this up, and it seems like a little bit non-trivial, to be honest. I was looking at like this project WL clipboard, and there's a lot of stuff in here. But if we look at like the implementate, like their paste application, they have blah blah blah. Here we go, main. They like open up a Wayland connection. They talk to the Wayland registry, which like is something we're familiar with. They get like a seat, which is like, I think we're a little less familiar with that. And then they talk about like device managers, and the device has like some like attributes on it, such as needs pop-up surface, which says like if they need a pop-up surface, then they have to make a window of some form in order to do pasting. And I was trying to figure out like, okay, what determines the use of needs pop-up surface? It's like, oh, okay, there's this like kind of like weird fucky macro in here where they have like device init with type, and they call init for what looks to be different Wayland protocols, I guess, right? So there's like WL data device, primary selection device, ZWP primary selection device, and if we look at like the implementations of this like init macro, I lost it. Here they have needs surface as like an argument this thing. And so if we want to do this without popping up a window, which we might want to do if we're trying to make like a generic clipboard handling library, they have needs clipboard for data device. They needs clipboard for GTK device. But I believe the ZW primary selection device one, I believe there's one of them in here that does not need it. I think here, ZWLR data control device V1, 0. He does not need that. So if we were going to use SDL or GLFW anyways, but we still wanted to create, work with the clipboard, it might be nice to try to use this interface. So I was then looking at like Wayland.app, and I was just trying to look at what is this thing, ZWR data control, here, this thing. And if we scroll down to the bottom, he says Kwin supports this, Mutter does not, Sway does, right? Whatever. For now, let's start there. Let's start there. We will try to make a Wayland client that pastes using this thing because I support it, and then we'll think about like the other cases later. Ilionte is in chat saying you can create a surface without mapping it, so you don't need a window per se. That's interesting. I think I saw when I was like spelunking this code a little bit that they did have to make like a 1x1 pixel pop-up window somewhere. That would have been in types, probably pop-up surface. I think I saw in here something about like a 1x1 pixel window. Width height. Yeah, so even in here, I saw that they are in fact creating like a shared memory object and like binding that to the surface and stuff. So it's like they're actually like doing like the whole shebang, even though the width and height is only one. So maybe this is unnecessary, but my one reference, they are at the very least doing it. So I wanted to bypass that a little bit. So plan of action is trying to get something from the clipboard, then we try to get an image from the clipboard, and then we can go try to go the other way. That's about it. And let's just kind of see where we end up, you know? So last time we worked with Wayland, we wrote our own Wayland data marshalling stuff. I would like to try working with the normal, reasonable lib Wayland this time. So let's kind of start there and just try to get like a Wayland client that does anything. And since we've kind of we've looked at this before, let's look at our Swayland client. We can kind of see the flow of like negotiation of data should be very similar to whatever we did here. It's just that like the way that we do that is maybe a little different. So we create a Wayland display. We try to get the registry from the display, and then we try to bind some more interfaces. This sounds very familiar. So here, then we say, we look for events, and we get events from the registry, and we try to bind those things. Okay, that sounds very familiar. So maybe since we like I'm typically like not super into using ChatGPT for writing code, but in the case of like trying to get some sort of like initial example code for something that I already understand like the internals of, I'm kind of okay with it. So can we say like, can you give me a simple Wayland client using libWayland? Let's just see what he gives me. Okay. So he connects to the Wayland server like we've seen before. He then gets the registry like we had on in our example, right? And then he adds a listener, which I presume like are callbacks that will be called when the Wayland system does something. Then he calls a round trip, which will basically read some events from the Wayland socket, and then dispatch. I would assume that he will dispatch registry events to this like handle global thing that we set up, and then does this. So this seems like a pretty reasonable initial program. So let's just kind of like try this and see what happens. Okay. So let's get into our Nix shell, which we actually have here already. This is an empty project, so we'll get there eventually. But I guess let's do this. Let's just see if his example is functional or not. Right? All right. Okay. So his example is useful, and this gives us a list of all of the interfaces that we can interact with. And so what we can look for is whatever fucking thing, whatever fucking thing we were looking for, which is I think it was this thing, WR data control. So we're basically looking for this guy, which we should see in here. Yes. Boom. Okay. So we have this interface. And then we can start running with it. Honestly, your Zig bindings were better than the callback hello lib Wayland client puts through. I believe that that's true. I want to give it a shot once, and if we go through this and we're like, fuck this noise, then I think that maybe it's worth going back to our silly Zig, our silly hand-rolled version. Hello, may I ask, have you ever developed something for remote host using NVIM? That's what's keeping me away from using it. I will work a lot on remote hosts. I don't understand. Vim is like the best option for if you're working on a remote server, right? Because all you have to do is SSH into the box and then type nvim, and then it's exactly the fucking same. That's like one of the reasons that I use it. Okay, let's turn this into like a Zig example. So we'll do our typical build Zig, main Zig. Let's get a little crazy. Let's look at our test C. We'll just kind of yoinkies this shit and paste it into main.zig and then start adjusting this. So this should be a function handle global with call conv C returns void. Yep. And then we just need to do like, this is context of any opaque. This is a registry that is a pointer to a CWL registry. ID is a U32 and interface is a C pointer to some U8s. And version is a U32. Okay. Then we're going to go, this turns into a std debug print here. And these things need to go in squiggle brackets. All right, one down, some more to go. This is a const registry listener that comes from this stuff, which is, what was it? It was a CWL registry listener that has handle global, which probably comes from like global or something here. Not sure. We'll check that in a second. Then we have a main function, which returns void error. And he's going to do this. This is lowercase in this language. Let's do a const c is equal to c import like this. And this thing needs a c include of Wayland.h, I assume? Maybe Wayland client. What did we include in test.c? Wayland client. Okay. We need the standard library as well. Video stuttering. You freeze from time to time for like a second. I don't think it's me, is it? I have a few dropped frames, but not a lot. Is it bad for everyone else? I would like to, if somebody else has the same issue, I would like to know. It did for me a moment ago. That's fucking annoying. Sorry, guys. Is audio starting too? Is it like full gone? Okay. So I kind of like the idea here. I've kind of like fallen into this pattern before. So this thing is going to return like a nullable pointer. But I would like to have like some function that checks if the thing is an error, a null, and unwraps it late, and if it's not. But we can come to that later. So for now, we'll just write fix me null check, and we'll just delete this for now. We get the registry. We bind our listener to the registry with a lowercase null. We do our round trip. We do our event loop, and we do this. Okay. Zig build. We do not have anything in our build.zig, so we need pub function build, takes in a std builder, returns maybe error. We have to import the standard library, so we have std build, and we do add executable, and we'll call this name is going to be clip. Root source file is the source main zig, nice. Optimize is optimize, and target is target. Okay, which means that we need a target and optimize. So we add standard optimize option, nice, and target is standard target options, nice. Okay, then we need an exe from this thing. We have to install it to get it into the output folder. So b install artifact exe, and this should be good. This should be good. I guess we probably need to link lib Wayland for this thing to not fall over. What key combo do you use to convert to lowercase? GUIW. Yeah, what you said. What you said. He's mad about like some unused parameters here, so we'll just kind of whoop and whoop. Okay, and C import failed because we need to link system library of Wayland. And we need to also link libc. And hopefully that solves our problems. Close. He can't find Wayland. Is it Wayland client? Is that what we typed last time? Might have been. Might have been. Give him a sec. He's gonna think. Close. Okay, so expected type this shit show of characters, found this shit show of characters. So first argument same, second argument same, third. Oh, fourth needs to be const28. Sure. But otherwise it seemed okay. Now he's still mad, const28, U32. What's the difference? Any opaque, WL registry, U32, const28, U32, call conf c void. What's this? Why is he angry? Note parameter 3 cannot be cast into the. Oh, I forgot a C pointer here. Dude, he's so picky. There we go. And then we need to do like discards here for parameters. Then we need to return nothing because we don't return 0 in this language. And then here he's mad at format because I was supposed to change these into string, number, and number. Okay. Cool. So we are back. We're so back. Okay. Now let's quickly try to just do some like return checkings. So if we do like an integer check, we can take in a val of c int and return void. And he's just gonna say like if val is less than 0, return. I guess we're gonna have to pass in an error here. So we're gonna say like is any error, I guess. Else, and I guess that's it. So then we can do like try c int check of this, and then say that we have like error at listener. Yup. Like this. And then we can do like c int check of, I don't know, error something. Round trip. Okay. And then we wanted to null check these as well. So can we do like c null check, which is going to take in some sort of pointer and return something else. I don't know what yet. I guess we're going to have to like figure that out. So we're going to like take in some sort of like child pointer. Non-null pointer, I guess, of some sort of like thing. And I guess we're going to be like switch on type info of t. And I guess we'll just be like, I'm not really sure what our options are here. So can we just do like this for now? Then we can return non-null pointer of type of pointer. And we say like if pointer is equal to null, return error. And then otherwise return pointer question mark. Right? Seems reasonable. Seems reasonable. So then we can do like C null check of this thing. Otherwise we have like error make display. Okay. And then here we have like the same thing, probably where we have like C null check of this thing. Otherwise we have like error make registry. Or maybe get registry is the right word here. And these need to be tried as well. Okay. So can we like return t for now, just temporarily? So expected error union type found this thing. I guess that is true. So that means this has to return an error non-null pointer. And then here he's saying that we have an optional thing, right? So we just say if we have optional, we have a child thing or optional info, and we return this. Should be fine. Nice. Nice. Nice, 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 nice. Okay, so now we've got our fix me here. We don't need this. We don't need this. And I guess what are we going to do here? We're going to like add a listener to the registry listener. And we need to like in this figure out, we need to like write down when we find this thing. Right? So we're going to be like if interface So I guess we want like, we have like the C string of interface, right? Which we're gonna have to turn into a zig string. So we're gonna like std mem span of interface C. And then we're just like, if we have a interface that is equal to this thing, we're going to try to bind that thing. So I think it's like WL registry bind. What does this thing take in? He takes in the registry, the arg name, the interface, and the version. So it's probably like this, and then we need the registry as well, which comes in here. And this returns a pointer to anything, which I assume means that like, where's our ChatGPT guy? Is he gone? Did we lose? Oh yeah, we did. Fuck. It's okay. I think that this is like WL registry bind. This I think returns like a pointer to the thing that we're trying to make. WL registry bind. This is the protocol spec. I want like client API. Here we go. No. Maybe here. Blah blah blah. He doesn't have a bind in here in the fucking page called binding to globals. I don't see any usage of WL registry bind using registering globals. That's not what I want either. Oh, here we go. Yeah, so he has like bind to the compositor interface here. Name. Interface. Oh, which is different than this. Okay, so it looks like if we want to look at this thing, we would want to do like ZWR. We forgot a crucial part here in that this is an extension. Fuck. Hold on. So we need to actually create the C files for this API. It's important. So let's go to this. Grab this thing. And we run Wayland scanner, I think, is what we saw in the past. So this creates like C files out of the XML for this interface. And I think that we want client header from this to, I guess we'll call this like control.h. And I spelled Wayland scanner wrong. Okay, and then we have this thing now. Nice, 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 nice. And then this needs to get added to our C include. So here we're gonna go like C include of this. Okay. And then here we need to add that to our list of include paths. I think it's just like this. I think. Okay. So now we should be able to be like bind to this ZWR data control manager interface. I think he's not automatically resolving, so we might have to restart our editor here to make that show up. Does this exist now? Control interface. WL compositor interface. And what are we're looking for? I guess it's probably something that lines up with this. ZWR data control manager. Okay. Here we go. I found it. Here, this thing. Right? Yes. And then this gets applied to a ZWR data control manager. We'll call this like control manager is going to be a pointer to a ZWR data control manager v1. All right. So if we do this, we should be able to go down here and print out this thing. Let's make this thing nullable and start it as null so that down here we can check if we got it. So here we should be like data control manager, and if everything works, we should see expected type this found any opaque. Oh, I see. So we need to pointer cast this. All right. Format is angry. Cannot format optional without specifier. That's true. That's true. Can we just write any here then? Okay, now we need to... We're missing an undefined symbol to this thing. I think that here we probably need to generate some C implementation of this stuff as well. Of the protocol. So I think that we have like private code of this to source WR data control.c probably. Yeah, here we go. Nice. Which means that this needs to be put in the executable. So exe.add C source file of bpath source WLR data control dot C. Yep. Do we build this time? Okay, so here we do in fact have this thing bound now, which is good. And now we can start trying to figure out how the fuck do we use this to copy paste stuff. So now that we have it, let's figure out what are we building. We're trying to paste an image from the clipboard. That's about it. This protocol allows a privileged client to control data devices. In particular, the client will be able to manage the current selection and take the role of a clipboard manager. Warning, this is experimental and backward incompatible changes may be made. I don't give a shit. Backward compatible changes may be added together, blah, 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 blah. Sure. Okay. So create a data device, create a data source. So this, I would imagine, is us pasting and this is us copying, maybe. Can we look at like the implementation here in WL clipboard? How do they actually like do the paste? You know? So they have wlpaste.c. In here, they must do this kind of like towards the end. So they find a seat, they find a device manager, they get a device from the device manager. So we probably are looking at this might be the device manager I think we saw in their implementation somewhere. Then they have a callback that they call on selection. Okay. So this takes an offer in. And they receive the offer with a pipe. Interesting. So do we have we have an offer here. So how do we get an offer? An offer comes from, can we just look for like offer in here? So this comes from a control device. So it looks like we have like the manager. We probably extract the device from the manager. Then we wait for an offer from the device, would be my guess. And then our offer has like a receive call on it as well as an offer event, which has something to do with MIME types. So I guess let's just try to get one of these data devices and see what happens. So which means we need a seat. Where do seats come from? I don't remember. Here we go. So WL seat. A seat is a group of keyboards, pointer, and touch devices. This object is published as a global during startup, which means that if we look here, we have a WL seat. So that means we want to do something that's like var seat is a WL seat. And we kind of want to do like the same thing here where we check for if we have a WL seat, then we will bind the seat to this thing using probably a seat interface, maybe? So what happens if we do that? What happens if we do that? Are you sure that's the protocol you want to use? The core protocol has this data manage thing already in it. The reason that I'm using this version is because I saw in WL clipboard they have this needs pop-up surface, and I was trying to dodge it. Right? I'm making the assumption here that like they are correct about this, and I do not want to have to create a window if I don't have to. We can always like go back to that if it makes more sense, but for now I'm just trying to get something that works. And I think that I was skimming these protocols and I looked at the data offer thing here, and the data offer from like the raw Wayland thing matches this Z like WL roots version pretty closely. So I'm making the assumption here that it's close enough. And that this will be more likely to get me what I want. But yeah, I think that you're right that it would make sense to try this as well. I'm just going off this if statement to say, oh, I don't want to deal with that shit right now. Compositor compatibility seems pretty bad on that. I agree, but it exists on my mind right now. So I think that likely what they have done in WL Clipboard, where they have like 4 implementations and they pick the one that makes most sense for them, I believe that is probably the correct answer later. But I just want to do something now. And when I was Googling this like WR data control, I think I saw that like it's like a similar to the WL data source interface, but with some improvements. Right? Whatever the fuck that means. Whatever the fuck that means. So am I sure? No. Do I think it's likely to be good enough? Yeah. Okay, so we have a seat now, and I guess what we have to do is we have to create a data source with this thing. So I think usually what we do here is we get all of the interfaces that we want, which we have now at this point, and we should now at this point be able to be like data control manager, like CWL, what is it? ZWR, data control manager. Is there like get version, get data device? This is what we're looking for, right? So this thing takes in the control manager as well as the seat. So we just pass in data control manager and seat like this, right? Then what does he return us? He gives us back a data control device. And we can do like a C pointer check, C null check here. And we can say error, no data device here. Okay. Okay. Sure. Then we decided that we want to take that device and maybe we want to register some callbacks to him. I wonder what the difference between source and device is here. Because source lets you offer MIME types, okay, and request for data from the client. Oh, okay. I see. So the device lets us copy stuff, theoretically. And then I assume that the offer is like the other side of this. The offer is, well, so blah, blah. Yeah, so will be used in either selection event or the primary selection event, immediately following offer events. The new data offer object will send out offer events to describe the MIME types of offers. Yeah, so I assume that data offer is what we're looking for. So can we do something that's like How did we add a listener to the registry? It was like this. So we want like probably ZWR data device. It's not a device. Yeah, it is a data device. So we want like add listener. Nice. Which takes in the data device, I think. And then we need a device listener here. So what's going on there? He takes in this like listener structure, which I believe just like sets basically all of the green stuff here. We create like functions for each of them, right? So we have like data offer selection finish primary, data offer selection finish primary, right? So that's kind of what we're doing here. And I guess we think that we only care about the offer. So can we do like v1 listener? Yeah, nice, nice. And we want data offer is equal to data offer, handle data offer maybe. So that means that we need like the type of this thing, and we need to create a function out of that, I guess. So he's going to take a context. He's going to have the device. I guess for now, we just kind of stub all these out until we know we're going to use them. And then we implement this. So can we just say like std debug print got offer. Okay, let's just kind of start here and see if it gives us what we want. Okay. He's mad because he expected this thing found something. I think I forgot to write try somewhere. Yeah, we forgot to write try on this. Okay, so he gets an offer and then immediately crashes because this thing is null. So I guess we actually have to fill in the whole fucking structure, I guess. So do they all have like the same signature? Offer, offer, nothing, offer. Okay, so can we like, I guess for all of these, we'll just use the same thing. Okay. And then the other one was finished is equal to, this one was different. This is going to be handle device finished. Is that what this thing is? What does like the finished thing do? Data control is no longer valid. Yeah, okay. So handle device finished. Hello, where are my fucking keys? There we go. Handle device finished will be like this, and we'll say got finished. Boom. Okay. Is that a little better? Nice. Okay, so we see 4 got offers. If I select stuff, we see 2, and then if I copy, so we have 1, 2, 3, 4, 5, 6. So we're seeing double up. Okay. Interesting. But it does seem like we do have some form of like something going on, right? We have some indication that a copy has been started. Now, what are we supposed to do here? We get a data offer. Okay, copy data to the primary selection. The data offer event introduces a new control offer object, which will subsequently be used in either this or this. So either the selection event or the primary selection event. Immediately following the data offer event, the new data offer object will send out control offer. So this thing will have events associated with it that tells us the MIME types that it supports. Do we care about that? We have like this receive thing after. Okay, so to transfer the offer data, the client issues this request and indicates the MIME type that it wants to receive. The transfer happens to the passed file descriptor, typically created with the pipe system call. The source client writes the data in the MIME type representation requested, then closes the file descriptor. The receiving client reads from the read end of the pipe until end of file and then closes its end. Okay, interesting. So we have to give it a MIME type. Then we ask it to send us some shit. And this MIME type comes from the supported MIME types here. So I guess let's just start by reading the MIME types. So I guess that means in here, they're giving us a new offer, right? And so we're trying to do something that's like, we're setting up like a new offer listener, I think, which has like an offer callback. Okay. And the offer callback has like this thing. And we're going to call this like handle mime, I guess. Okay. And I guess that means that this is the MIME type here. And this is the offer that it's associated with, which we probably don't use. So let's just like print out the MIME types right now. Okay. MIME. Okay. So then here we'll say handle MIME. And we have to like register this thing somehow. So it's like CWR, ZWR, data control offer, v1, add listener. Okay. Which takes in the listener and the data. So we just do offer listener and data. I'm a little concerned about this being on the stack. I'm not really sure what happens there, so I'm just going to put it out here just so that I'm sure that like the pointer to this thing will be valid for the whole time. And we bind this to the offer. Okay. And then we need to do a C int check, except this other thing doesn't have like, this is a C function, which means that we have to just kind of go like, I don't know, error, add listener, and then I guess we'll just catch this thing and say, log error failed to add listener for data offer. What language is this? This is Zig. Okay. So I click on something here, and we see that we have MIME types of plain, UTF-8, and plain again. We're seeing that we are double binding this thing, which lines up with the fact that we're getting the offer twice. Probably the data offer is like, how do we know what this is for? Like, is this for the clipboard? Like, it seems to be, but like, how do we know that? Because there's multiple. Does this thing have a way for us to like ask for its purpose? No, he only tells us the MIME types. So it must be that the primary selection and selection are different, right? Can we do something that's like handle data offer here? Can we make like handle primary offer, handle selection offer, and then handle data offer as well? So this is going to be selection offer, and this is going to be primary offer for now. And then can we just be like handle selection offer, handle primary offer, and just like kind of get a feel for like what the fuck is going on here? So this is primary on any selection. I'm only seeing primary. Did I double data selection primary? Okay. So why am I seeing failed to add listener? Okay. So I get a data offer. Oh, I see. So we get a data offer, and then we got a primary offer after because we're failing to add listener for the primary offer. I see. So can we like say that our data offer does nothing? For a second. And then do we see a difference between like primary selection? So if I hit copy, control C, I get selection offer. If I just select text, I get primary offer. Okay. That makes sense. So really, maybe we'll just do like ignore data offer here. And then we only care about selection for now. So let's do this. It was this one, I believe. Let's try it again. So if I select here, nothing's happening, but I hit Control C, got selection after. It's for clipboard and drag and drop. It's a generic data transfer thing. But then like, what I'm a little confused about is like, how are you supposed to know? Because they come in the wrong order. I guess you like process the data offer unconditionally, and then you like shuffle. You like once you see the selection offer, you go, oh, just so you know, the last thing that we processed was for clipboard, which is kind of bullshit, but it is what it is. Can we look at like actually? It might make sense here. So, yes. Okay. Hold on. So if we see a data offer, this creates the object, but a selection does not create it. He is just a reference to an existing object. Same with primary selection. These are just existing. These are existing. So I see. That makes sense. So you're probably supposed to like pointer compare those in some way, shape, or form and do something. But for now, we'll just do it this way. Okay. So we handle selection offer. Dude, this is like impossible to read. Can we do like this? That's a little bit easier to read. And okay, so we add this listener, and then we get some MIME types for this thing. So what's a little weird here? Where is like the MIME type list here? So we're getting this many times, right? Wait, are we? Where are my MIME types? Do I have to do this after the data offer? Is it possible that we're getting this selection offer after the MIME types have happened? I think so. So I think we have to actually do this here. So here we'll say like handle data offer. Okay. Hold on. I think this is making sense. So the sequence is this guy sets up the MIME type listener, and then by the time we get to this, the MIME types are already known. Maybe. So if we have like a global, it's like MIMEs. Is it safe for us to copy these strings out? I don't really know what like the rules are about like the Wayland string inputs. I would assume that it's not safe to like keep references in them, so we probably have to copy them out. Can we do like this? And then I guess we need like a allocator that's available in these callbacks. This is gross. I guess this is what the context is for. Okay, let's start by doing this here. Just because it's easier for now, but then we'll clean it up a little bit later. But we'll say that for now, we'll do everything with globals, and then we'll figure out how to bind contexts later. It's fine. So if we want to copy the MIMEs now, basically when we get the data offer, we should clear the MIMEs. right? We also have to free each of these strings in here. So we're going to do something like this. Okay. Then when we get a mime, we're going to say mimes append alloc dupe. Yeah. Yeah. And then this is going to be like duped is going to be this, and then we like catch return for now. And maybe we log here failed to alloc mime. Okay. Hello. And then we do append catch stood log error failed to append mime. I think we don't need new lines on the error logs. Oops. So we do this. Okay. And we append the duped. Nice. Okay. Then on selection offer, now we know what our available mime types are. So can we just be like got selection offer available mimes are these. Okay. Ignore data offer doesn't exist anymore. Mimes is not for mimes. It should be items. Okay, and then append is mad because we need to specify our allocator. True. Available mimes. Okay, can we print these as like strings? For, and we'll do like for my mimes items mime print out this like this like this, and then this goes away. How's that look? Available mimes. Yeah, okay, that's looking pretty good. Proxy already has listener. Interesting. So I hit Control C here, it's fine. But if I select, we're double offering. Oh, because when I hit Control C, probably. Oh yeah, guts all. I'm actually not sure if it's like recreating the offer here. Let's do stood debug print new data offer. Let's just see what's going on here. So I select. We see double new data offer. I hit Control C. Okay. So if the offer is supposed to come in, like this data offer is supposed to come with a new ID, it seems like they're calling this twice, but one time without a new ID, which is a little odd. So probably we need to add like a check here that's like if we have already seen this, which is annoying. But it's fine for now. For now, we'll just ignore the problem. The ultimate fix. So I'll say fix me discard if offer has been seen. Was it always like this? Did this just change recently? I don't remember. It's fine. I think it's yeah, it's fine. It's fine. Okay. So now I guess when we get this mime type, let's just pick the first one. So how did they say we do this? We call receive, and we pass in a file descriptor that's created with pipe. So we do like std POSIX pipe. Nice. Which returns 2 file descriptors. Where 0 is the read end, 1 is the write end. So we should probably be able to do something like this. Try doesn't work, so catch return, catch std log error, failed to create pipe, and return. Okay. Okay, so now we should be able to do like, look at the offer. Okay, and we should be able to receive this offer. So it's ZWR data control offer receive, who takes in the offer as well as the MIME type and the file descriptor. So we offer, we look at MIMEs, items 0, and the file descriptor, right? Which we want to give him the right side. We'll look at this thing and we'll say if this thing fails, we have like error receive, catch std log error, failed to receive data. Okay. Okay. Then I guess we should just be able to read the stuff in Rx. And I guess we want to go like, while true, we read some stuff into some buffer, right? Right? Something like this. And we go like, if len is equal to 0, break. But before we do that, or I guess after, we can just print out what we got. Okay. So here we can say like received data. Std debug print received data. Okay. I don't know. Let's see what that does. Mimes items. What's he mad about? Oh, because this thing needs to be like a null terminated thing, which means that this needs to be controls with set null terminated. And when we dupe, we need to dupe z. Should be fine. 69 is mad because does this thing not return? Oh, interesting. So this can't fail. Okay. And then this needs to be catch std log error failed to read data. I don't know, something like this. Too few arguments. Where? Here. Like this, I guess. Okay, so it looks like we are now stuck. And I would guess that the problem here is that we have like, this probably doesn't actually send the data. I bet this like queues something up in the Wayland queue, and you have to do like WL like round trip is what we've seen before. But I think it's like display dispatch pending. Probably flush. I bet you it's flush. I bet you it's flush. I wonder if this is legal from within a callback, or if we're in a fucking world of hurt here. Let's just see. Let's just see. So if we do this, we can do C int check here. We'll say error flush. And stood log error failed to flush. Something like this. Seems like he was fine. But it does seem like we are still stuck here. I mean, let's just like do like a... Can we do run this with GDB? And just kind of look at where we are? Yeah, so we're stuck in this read call. Oh, wait, hold on. We do see some data coming out. Hold on. So if I select copy or KD Plasma Virtual Desktop Management, oh, okay, that's showing up. So it just means that the read is not finishing for some reason. It means that we've gone through one iteration of this loop. And if we were to break out at the end unconditionally, yeah, it looks like that's kind of working. So I select this, I hit paste. Yeah, okay. Or hit copy, I mean. That looks kind of right. That looks kind of right. So, okay, so we have like the kind of like the flow work like correct here, right? So we ask for some manager of data. The data manager will be like, hey, somebody's offering you some data. Here are its available MIME types. And it is for a copy. And then we say, oh, it's for a copy? Can you please just give us that data really quick? And we pass him a file descriptor that he sends the data over. And then we look at it. Now, I thought, like on the receive here, it said that we're supposed to read till end of file, which is kind of odd. Oh, I wonder if the pipe file descriptor here, I wonder if we're supposed to close our TX handle. I wonder if it's like something silly like that. Like there's two writers to this thing. And maybe that's a problem. Cannot close TX. It's like a possibility for sure. There's no error here. That's surprising. Oh, yeah, wait, hold on. Yeah, okay, that's doing it. Yeah. Okay, that's interesting. Interesting indeed. Okay, so we have, you know, something that works. What happens if I hit copy here? No, I guess we should say get anything from the clipboard is like done. And now we're looking at get an image. So that's pretty interesting. So we're seeing a list of MIME types, right? Which kind of indicates that we could ask for any type of this thing. And I guess what this means is that when we get the data offer, the data's not ready yet. Right? This is kind of like heavily indicating that I can ask for a PNG and then color paint will serialize that thing as a PNG when I type receive. That's pretty crazy. Which means that if I copy in Color Paint, then close it, then run this application, I wonder what the behavior is. So hold on. First of all, let's run this thing. And if we run this thing before, I don't have to type copy again. It gets whatever was offered before. So if I hit copy and then I close this and then I run this, it's still there. Kind of. What is happening here? Maybe the compositor caches it. It's only a selection offer, not a... So here I copy. We actually get the PNG here, I guess. And if I run this again, we get the PNG again, right? Right, we see it again. Now if I close this, run it again, we don't get it. Which is kind of interesting. Maybe that means that like it might mean that like KDE or like the KWin has cached the offer, but the offer is invalid because the other application cannot serialize the data, right? Because the data at this point is like not there. I wonder if, does that mean if I go into like, right, yeah, see there's like some sort of, something weird going on here. If I go into, Color Paint, and I copy this, copy, close Color Paint, right? Reopen it, paste. That's interesting. Okay. Right? So if I okay, let's try this again. So I go smile, copy, paste, right? So paste, good, right? Open up a new Color Paint, paste, good, right? Close this Color Paint, paste. Ah, this explains some absolute bullshit behavior I've observed in the past. That's really interesting. So, oh. So if I close if I close the application that's offering the data, the new clipboard data gets the list of MIME types that used to be there. What the fuck? That's crazy. That's so weird. That is so strange. Okay. Yeah, because you're sending the file descriptor to the other side. If the app goes away, there's no way to send the file descriptor to. But what's weird here is that the file descriptor is getting data. The file descriptor is right, like we here received data. Oh, unless these MIME types, no, it says received data here. Can we like literally type out like read from file descriptor is this, finished reading. Like, let's just be like fucking super clear about this. Yeah, see, I'm seeing like read from file descriptor, the list of MIME types, and then finish reading. So somebody is putting the list of MIME types in here instead. It's getting it from the KDE clipboard manager. If you disable that, it goes away. What the fuck does that mean? KDE clipboard manager. Clipper. Configure board. Maybe it's like kind of like baked into KWin. I don't know if you can do that on Wayland. Used to be able to on X. So, but that means that like somebody, presumably Kwin or somebody in KDE, has this like what I would consider an absolute dumb fuck behavior. I shouldn't say that. That's rude to whoever wrote it. But it's like not the right behavior where it sends the list of MIME types into the paste buffer. WinV doesn't do anything for you? What the fuck is WinV? Oh. Oh, I wonder if it's literally for this. So they might do this so that you can tell what you've copied by looking at the history, right? So if I go into here and I say like smile, right? Let's copy some text first. Copy, 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 copy. So I hit WinV. Now I see what we just selected here. And then if I hit Control C in this and hit WinV, there's actually nothing. Okay, but then if I close this and hit WinV, also nothing. So there's probably something about running my app and trying to get that stuff. No, wait, where is my... I want to go back to this test case where I copy this thing, copy, paste, run this. Fuck. Close this, discard, run this again. So at this point, I don't see that in the history. And here, now that I've hit WinV, I feel like the behavior is different. Right? Before it was smile, copy, paste, run application. He pastes that shit. I close this, run application, and I see the list of MIME types. Now when I hit WinV, still nothing. But if I go into color paint, hit Control Paste, something has changed. Maybe, did I select this by mistake and just forget? I don't think so. I'm pretty sure I'm pretty confident that we were seeing a list of MIME types, and something has changed now. So there's something strange going on. Something strange going on, but whatever. Very interesting. Very interesting. Okay, so can we try? I guess if we are handling selection offer, we have to like categorize the available MIME types to us. Right? We want to do something that's like a... Okay, I want to get out of this like C calling convention shit. I kind of want... Can we like start moving this into like something that sucks less balls to work with? Like, can we start like putting stuff where it belongs? Something like this. Do we... Maybe we take the pointers off these things, and then we do something that's like... on the first thing we do, the first thing we do is like bind registry items, which is all of these. So interfaces is equal to struct here. And I guess we'll have like all of these things, but with question marks in front of them. Okay. Then when we do our registry listener, we add interfaces here. Okay, yep. And I think that this is also going to have display is kind of unconditionally true here. Okay. Interfaces. Binder. Whatever, it's fine. So this is going to have this and the registry unconditionally. I think we don't even really need the registry in this. I don't think. We probably don't need the display here either, to be honest. When we run our get registry, our registry listener now, this is going to have like some context that comes in, and we're going to say that the context is an interface pointer. So self, maybe we even call it, is a interfaces, is a pointer cast, a line cast from CTX. Okay. Which means that we should now be able to be like self dot here and here. which kind of means that we don't need any of this anymore. Okay. Then app, we're going to do like from interfaces. Maybe we just do this for now. So we like do this, and then the interfaces should be valid here. So can we do interfaces dot like this, and then comment out everything below for a second? Fuck. We have to fix this stuff as well. So can I just like comment out a fuck ton of stuff here as well? Comment out all of this. Interfaces is missing data control manager, so we have to null these things out initially. Okay, so we're chilling there. So now we should be able to construct our app. From here, we have display is equal to display. We have data control manager is equal to null check of interfaces dot data control manager, or no control manager like this. Okay. And then the other one was the seat. Right, like this. Now we should be able to use, I guess our app probably wants a data device as well. And so we'll go like data device is equal to, maybe not. Maybe not, we'll see. So maybe we just pass in the app here. Okay. Okay, like this. Handle data offer now. All of this stuff we need our context to be passed in. So handle data offer is going to take in a context, and we have a const app is an app, which is a pointer cast, align cast of context. And then can we just do like app handle data offer or something? Reset mimes, I guess. Yeah, we'll call it handle data offer, and we pass in the offer. And then now we can be like catch here and just say like failed to handle data offer. And we can say even why. And really, we should maybe even do like fix me backtrace, so that we can get like a nice little list here. But that's fine, fine. Okay, so now all of this goes away and gets moved, kind of like into app. Yeah. So we're gonna have mimes here, right? Something like this. And it was handle data offer. It takes in ourselves as well as the offer. Data control offer v1 or something like this, right? Okay. Which is all of this stuff. Okay. Which means we need our offer listener somewhere. which is this, which means that we need handle mime, and handle mime is going to do something similar where he's going to be like, oh, first of all, can we get rid of mime? All of this goes away. We store an allocator here, and which means we have an allocator is equal to stood mem allocator here. Okay. Which means that this we use self.alex, self.mimes. Okay. And then here we have like a similar thing where we have like a solid context. This is going to turn into an app, which means that when we need to pass self here for the offer listener. And then here we're going to be like const app is equal to align cast pointer cast ctx boom, and then we're going to like app dot push mime or something, right? Which takes in self as an app and mime as a C pointer to a const u8. And then we can kind of start doing this stuff in here without having to worry about like catching stuff. So we can just write like boom 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 boom, try self alloc dupe, no catch, and then try mimes append, no catch, which makes it okay, which means all we just write catch here, and we can write with like the reason, and we can say like failed to push mime for some reason, right? With a fix me backtrace. Okay. Is that everything? Handle selection offer we probably need as well, Zig build. Yeah, so handle selection offer, we need the same treatment given. Same treatment where handle paste, we'll call it, or maybe we just write paste here. That feels kind of good. And maybe here we like stash the, I guess we'll like handle the offer. Maybe that's fine, yeah. Handle paste offer, which takes in the offer. Data control offer, I guess. I don't know, man. And I guess he's gonna do basically whatever we're doing in here. Okay. So like this, and then here we need to start being like self mimes. We don't have to catch anymore. We can just write try, simplifies this stuff. This is self mimes. We can write try here. We can write, then here we can write try here. Okay. Then here we can call this a context, and we can do like const app is a star app equals pointer cast align cast of context boom app dot whatever the fuck we called this handle paste offer of with the offer, and then again we do this. Failed to handle paste offer. Okay. Hopefully this is enough to get us moving again. This guy wants self.display probably here. Chillin'. And then app is missing an allocator here. Which means that here we need to make our GPA general purpose allocator and defer GPA deinit and const alloc is equal to GPA dot allocator. Okay. Are we chilling? Are we chilling? Close. We're missing mimes, which can just be default initialized. All right, and how's this looking? Is it still... I guess we need to run this stuff. Yeah, so it looks like it's still working, which is chill. We are still able to see the stuff on the clipboard. Okay, so now we were trying to actually like extract the image. And I think that what we want to do here is we want to start like getting a little crazy, right? We want to be like, find a pick, paste action or something. And I kind of want that to be like, we have some like mimes. Like this. Right? And then we want like action, paste action here. And I kind of want this to be like, we want like image is going to be different than text, right? That's kind of what I'm thinking here. But both of these are going to have like an associated mime type. So maybe this doesn't have to be a union. This can probably be like a struct, which has the mime as a, like this, right? And then we'll call this like a, like paste type is going to be either text or image. Right, so we can kind of get away with this. Now we're going to like iterate the mime types. Okay. And I guess we're going to look for like these, right? So let's just kind of say like we have like some text mime types, right? Right, we have these as our text mimes. And then we have a image mime. And our image mimes are going to be like a lot more selective about, I think. Hold on. So if I like go into color paint again and like, you know, copy here. I think that I just want like PNG only for now. Right? That's kind of how I'm feeling right now. So we'll say, for now, only images are supported, right? And I suspect that we should try to get this thing as an image first. So we can do like enum, string to enum of image mime. Okay. With, I guess like for mime, we have a mime, right? And we're going to see if this thing can be an image. So we take the mime and we say like, or else continue. That seems reasonable. This means that we're going to return a paste action. If we get here, it's like mime is the mime that we supported. And then the paste type is equal to text. I think that this should be, maybe we want to like cast this into something that we support, right? So we have like text is a text mime and image is an image mime. It's kind of how I'm feeling right now, right? And then here, the paste action is literally just like mime. Pick, mime. Pick, paste, mime. Okay, so this seems reasonable to me. Then we literally just do the same thing for text mime, I guess. And then we actually have to do a little bit more. Const image mime is equal to this, right? And then we have to do like return like text is equal to image mime. Oopsie, it's not my image. Right? And then this looks the same, but we just turn image to text. Right? And then here we'll return null otherwise. Right? And then down here, when we have a handle paste offer, we can say like, what are our available mimes? So then we'll look at like the pick paste mime from self mimes items. Okay. Or else return. We can't do anything about this. And so maybe we'll log an error here. We'll say like std log error could not find appropriate mime for paste. Okay. Seems reasonable to me so far. And then I guess we switch on the mime of some way, in some way. And maybe, do we even really care if it's an image? I mean, like theoretically we should, right? Theoretically we should. We should look at like, because we our behavior would be different. So maybe we will, no matter what, we are like extracting data from this thing. Right, so we kind of do all of this unconditionally. It just, now we have to like interpret that thing in a different way. So we're not going to bother printing. And maybe for now, we'll put everything in a heap allocated array. Whatever. That's kind of fine by me. So here instead, we're going to go like data append slice into from buff. Okay, we'll do that for now. That's fine. It's fine. If we have text, we can just print that text out, right? Oh wait, we need the mime type to go back. So this has to go here. We'll just do like, can we do this? We have like function toString, right? Something like this. And this is gonna be like switch on self text. We just return std meta enum. Do we just write tag name here? I think we do. Yeah. So then here we should be able to go like, why is it all out of whack? Handle paste offer. I must have like some open bracket somewhere there for it to close. Although I don't really see it. What's it fucking complaining about? Paste mime 176. Is that it? Yeah, it was. Okay. So here we take the paste mime dot toString. Then depending on the paste mime, we have text. We say we're going to like print out the text. Got pasted this string, right? Data.items. If we got an image, let's just write that in. We'll just maybe say for now, saving image data to image.png. Okay, so then we can do like std fs open or current working directory, create file, image png, and then can we just like write the data out? We have to go like f write all of data items. Okay. So he's mad because pick paste mime needs to return here if we can't find one. Error unit is discarded on write all. True, true, true. And then 89. We need to. What's he? Oh, do I need to return here? Yeah. Oops. All right. So if I copy this, we say pasted this thing. We forgot a new line, which is fine. And then if we copy an image, saving data image.png, and if we look at image.png, I guess we can look at it in Vim. We do see a PNG here, which is pretty fucking sick. Exeg open image.png. Looking pretty good. And then I wanted to see, so say now that we support like a JPEG on top. I guess we would want to say like function extension, right? And can we get like a mapping of like, can we get like a switch on self? And we basically like take these. And on this we say JPEG, right? And on this one, we say PNG. And that should allow us to like then say we get like i.extension here, right? And then I guess we say we should actually do this here. We say like file name is equal to, we'll have a buffer here, which we'll just have some U8s in it. And then we say std format buff print into this file name buffer as image.s, which comes from i.extension. Boom, boom, boom. File name is equal to this, which allows us to say that we're saving to file name. All right. He's mad because file name buff is constant. True. Okay, so now if I copy this again, oops. You shouldn't have dots in front of them. And then also, it looks like he's still picking PNG. Oh, because he's not sorting them by which one is first in the image list. He's picking them by which one is first in the list of mimes that were provided, which isn't really what I wanted. I wanted it to pick in order. So we almost need to like sort these by this. So can we do for now? Let's just do I want to do like a sort here. So we'll say that I guess we need like an allocator here. And we'll just like duplicate this thing so we don't like fuck up the input. So it can do like alloc dupe a list of inputs. We don't have to do that. I guess we do like std array list of mimes. Yeah, yep. This feels right. We're gonna go for each of these mimes. We're going to if it's an image mime, we do this. Okay, if we get an image mime, why sort when you only need the best match? Because in order for me to find the best, I either need to loop over the list like many times. Oh, I guess I could like find the minimum value. Sure. You're right. Sort maybe is a little bit strong, but I do need to at least look. I think I need to like cache all of the ones I support and pick the smallest one. So like min elem, right? Sure. Same thing. You are right though. Sort is overkill. So if we see an image mime, we say mimes append image is equal to im, right? And then we try to do a text mime as well. Yeah. Then we have text is equal to tm. Okay. Okay, so now we have like a list of these things. We should be able to like std mem min. Can't do min like that. Can we do like std sort min? Yes, we can. Which I assume will find the smallest element according to this less than function. Okay, which means that here we can take our sorting function. And this is going to take a context of probably nothing, would be my assumption here. And we have a mime of left and right, okay? And we're going to sort this saying that we want if std meta, is it like tag? Active tag of LHS is equal to std meta active tag of RHS. I guess we want like something like this. If they're equal, we return something else. We return LHS tag is less than RHS tag. And then we just make sure that we prefer images first. Order here is important. Okay. And order here determines which mimes are preferred. And we'll kind of say that here and here. Okay. So now we just say what? Can we like extract the union from this thing automatically and then just do like a left equals right? Probably not. Switch on LHS tag. Image. We just do like LHS.image is less than RHS.image, I guess. I don't know. This seems stupid, but whatever. whatever. So we take out the minimum thing of a mime, looking at the items, which is going to be our mimes dot items. What kind of game you making, dog? This isn't a game. This is not a game. And then does this return a thing? Or else return a null. I don't know how to code. Well, it's a hard life. I think this might be the wrong place for you then. I would say you feel free to stick around, but you might be a little bit lost. We are working on trying to get copy paste of images working in Wayland on Linux, which is a very niche topic. Which is why I'm saying maybe this is not the right place for you, but maybe it is. Okay, so this has that. I guess this thing can fail. That's true. And then we are not allowed to compare image mimes like that. Okay, so can we do like int from enum? This seems to be fine. Wait, where's it mad? So can we just do unreachable for a second here? Yeah, so here I think we need to cast these into ints. For this to work correctly, that is fine, and then we'll do the same thing here. If there's any zig heads in the chat, I would be interested to know if there's a way around this switch statement. It seems kind of stupid to me, but, you know, it is what it is. There we go. So now he's choosing image.jpg. Copy pasting text is still chilling. And I hit copy here, image.jpg. And can we like hex or file image.jpg? And that is in fact a JPEG. So that's really interesting. Really cool. Really cool. So yeah, that's interesting. So it looks like we've learned. So what did we learn? Getting data from the clipboard in Wayland was actually surprisingly involved, right? We had to like set up this whole Wayland thing, right? We had to set up a Wayland client. He needs to ask the Wayland compositor for a list of interfaces. We need to extract this ZWLR data control manager and WC. Theoretically, like there are also other interfaces that we could have used for this. We used this as like our first attempt because the Wayland clipboard claimed that this one did not need a window, which it didn't. The claim was that if we used any of the other interfaces that could provide the same things, we would need to create a window first, which I didn't really want to do. The flow is we extract those two interfaces and we create a data device out of those things. And then we need to bind like listeners for the data device essentially. So the data device, we go, hey, could you tell us when there is data available? And he goes, yeah, here's some data. When we get that data, we reset a list of MIME types that data could be associated with. And then right after he says we have some data, he then starts saying, yo, here's a MIME type that this data supports. He gives us like 50 MIME types and then says, okay, this is a clipboard thing. And we go, oh, clipboard thing. Well, now that we have this like list of mimes, I would love to try to figure out which one of those mime types is most correct or like the most relevant for us. And I will then ask the application who provided this clipboard, whoever hit copy, they haven't actually put any data anywhere yet, which is kind of interesting, right? We go, okay, now that I know that you could send us UTF-8 text, could you please, here's a file descriptor, bro. Could you please dump some shit into that file descriptor? And if it is more advanced, like a PNG or like an image thing, like in Color Paint, it's just kind of like working, it's like internal data representation. We say, yo, could you give this thing to us as like a JPEG? and it must call like the equivalent code of like JPEG save. It's just where it saves that thing is into the file descriptor we gave it, not into a file descriptor that it opened. So really, like on the sender side, it's actually like very clean, right? The clipboard support, the like paste, the copy support is literally just the same as saving, which is very interesting. And the save doesn't happen until we ask for it to save to give us the data. So that's really interesting. I would not have guessed this. I don't know what I would have guessed, right? I don't know what I thought clipboard transfer would be, but I was not expecting a file descriptor. But I mean, of course I should have, right? On Linux, everything's a file descriptor. And of course, if it's going post like through multiple processes, you have to have some sort of like representation. I think I probably would have guessed shared memory and not like, I don't think I would have guessed that we are encoding a PNG and decoding it on the other side. I think I would have guessed that there's like some shared memory of bucket of bytes. But in hindsight, that doesn't really make that much sense because you don't know when you copy what types of image buffers the other side supports. I would have assumed like some standardized thing like RGBA or something like RGBA 255. But does seem reasonable. You can pass it a mem file instead of a pipe for shared memory. True, but I would assume that it doesn't try to mmap that file on the other side. I would assume that the other side tries to write into that thing, and I think that if you provide a memfd, I think the write API doesn't work, if I remember correctly. The file behaves like a... Oh. Never mind. It can be modified, truncated memory maps. Okay, I'm wrong. But I mean, again, I guess you would have to ask for raw data. Which we might be able to do with... I think what are our like available MIMEs? I think I saw one for our like raw RGBA data. Can we list the MIMEs? Let's just do this really quick. I want to see now if that would be an option. Copy. So I think I saw in here RGBA. So what happens if we have like RGBA? I'm curious now. So if we put this here, we'll say that our RGBA extension is just going to be like raw or something. I wonder what that looks like. Copy. Hex dump image raw. Okay, so there must be some out of bounds thing for width and height. Can we copy a very small section to try to get a guess for like I want to copy like oopsies, almost like a 1x1. Oopsies, I don't want a text box. I want to select, copy. So we selected a 4x5 segment. I guess we should zoom in even more. Okay, so this is 2x2. Can we do like 1x1? Okay. Interesting. So maybe there is like, it doesn't really look to me like there is width and height information in here. It doesn't really look that way to me. But it also looks like there's like a bunch of garbage data kind of pouring out the side as well. I guess maybe image RGBA is like a thing that I didn't know about. Image RGBA. Maybe there's like a defined format here. MIME type. Yeah, I'm not sure. I'm not sure. It doesn't really seem to come up here, so there must be some sort of format associated with it. Otherwise, would there be way less data here? I would assume. But I don't know. It also seems like there's a bunch of zeros and a bunch of A's, so like who the fuck knows what the fuck we're doing here. All right. Well, that was fun. That was a fun little experiment. It was definitely stranger than I thought it would be. And I guess you could guess why GLFW and SDL don't support this. Because I would imagine that there is probably a different way that this behaves under X and a different way this behaves under Windows. And like, yeah, it's kind of interesting. Anyways, I think that's where we call it for today. Thank you for watching, guys. If you like what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so anywhere between 3.5 hours ago and now is what you should expect when you should expect us to be live. If you're new here, there are two segments of the stream. There's the 2 to 4 segment which we call like the mainstream, and that stuff all gets uploaded to YouTube. There's a YouTube link in the Twitch description if you want to check that out. And the 12:32 segment, we call it happy hour, and it's like you either got to catch it live or you got to hit the join button on YouTube or subscribe on Patreon to see that stuff. And the happy hour stuff is kind of like more laid back. We're trying to like refactor, clean stuff up, like make it so that like the code that we wrote today is less shit for tomorrow. The goal there is to not make like real progress that would be missed if you didn't watch any of the happy hours, but is important in terms of like code quality and ability to continue moving fast. So we might do like research. Like today we were working on refactoring our PNG decoder so that it works in like a streaming manner instead of on a byte buffer, right? That's the kind of thing where it's like it's not really worth its own YouTube video, but it is kind of fun to work on anyways. So yeah, that's what's up there. Probably we'll be back either tomorrow or Monday. I'm not sure if I'm going to stream tomorrow. We're working towards a image editor, which is going to be like the next big project. So I'm pretty sure that we'll start on that in the next couple days, but maybe I'll find some other small task that it makes more sense as like a lead up task before we get there. We'll see. All right. YouTube, peace out, and Twitch, let's find someone to raid.